All right, so let's get rolling. There was no homework due for today. Last time we looked at some light animation stuff just to give you a taste. Then you can go and do what you want uh, with that. Uh, we are working on our fight scene, if I remember correctly. And right now, we were doing the alternating between our two dudes, and we had them different animations for attacking, I believe. But we're not currently keeping track. Oh, we did add it for the player. So um, we were just adding in the ability to keep track of hit points and armor class for our monster and our player, and we, you know, want to deal with the back and forth of that. So let's go back to Visual Studio and review our inheritance model we had. Oh, I guess I'll open up one of the scripts from in here. I don't like opening up the project from within Visual Studio because it makes me nervous that it's going to zig when it should zag. Let's just go to whatever. It probably would be just fine, but that's my spidey senses on it. All right, so if you remember, we moved some stuff around last time, again, focusing on our inheritance model, where we created well, we already had it, but we've been adding stuff to our inhabitant class. We made this class abstract with the idea that we never intend to actually create instances of it. Instead, we're going to build things off of it like players, like monsters. So we decided that all inhabitants will have a name, they will have a current room they're in, and they'll have a HP and an armor class. That is anything that is an inhabitant, whether it's a player, which currently looks like that, or it's a monster, which currently looks like that. So at this point, we really don't have anything differentiating players from monsters. They all have names, a room that they're currently in, and then a number of hit points and armor class for the whole fighting thing. When we first create an inhabitant, any kind of inhabitant, we give it whatever the name was that was provided. We set its current room to nothing because it hasn't been put into a room yet. And then we go ahead and randomly generate its hit points and armor class. All right, and then we gave some additional abilities for getting some of those things, getting the hit points, getting the armor class. And as we go through our fight, we'll have to build in some abilities for them to take a hit and, and go down and things like that. Okay, so currently in our uh, fight controller, so we have a script called fight controller script. And that's going to be, actually, it's right here. All right, so here's our fight controller script. So this guy knows about our hero and our monster game objects. It also knows about the text mesh pros on those because it's going to set the hit points and things like that. It's going to keep track of who the current attacker is and then also the animator so it can play the trigger for the attack animation for each one, which we have made perform differently, but they both have the same trigger name. They're both called attack. All right, when this guy first starts, right now we're setting the heroes um, uh, hit points in equal to whatever it is inside of their text mesh, and we've already seen that in here. When I hit play, our player already has that stuff filled in. But right now, a monster is not populating. And the issue is right now we don't actually have an instance of monster. We haven't created any monsters. Rooms don't have monsters. So something we could do is inside of our fight controller, we could go ahead and create our instance of monster in here as a starting point. We haven't decided when monsters pop up in our normal dungeon yet. We just know that somehow we get to this room and we're fighting a monster. All right, so as far as we know right now, the only place that this monster exists is in this fight scene. All right, so since our fight controller controls what's going on in this fight scene, why don't we go ahead and give ourselves a private variable of type monster, call this guy the monster, and then inside of start, we'll say this dot the monster is equal to a new monster. All right, I think does monster take a name? Probably. So we got to give it a name for our monster. So let's go ahead and give him, what does he look like? Pink Ghost. Pink Ghost Monster. All right. So there's our monster. When we create an instance of monster, what happens? Well, we don't do anything special, but we do call the parent classes, which is inhabitants constructor. Inhabitants constructor tells us to go through and set the name, set the room, and randomly generate hit points and armor class. So we'll get that data from there. All right, so then back in our fight controller, now that we actually have a monster, we want to go ahead and probably set the, I'm just going to steal this line right here. So kind of the same thing we done for our hero, we're going to do for our monster. So we'll update the monster's text mesh pro to have the monster's current hit points, which is not in our singleton. Instead, it is the this dot, the monster, get HP. And remember, get HP is a getter that was born inside of inhabitant. So all inhabitants have a get HP, including players and monsters. So we'll get the monster's HP, we'll get the monster's AC. Oh. And now that should be updated on our screen. So we've updated the Text Mesh Pro for that. We hit play here. We now have a monster with some hit points and an armor class. And the monster's a little tougher than our player. He's going to have to, I guess, swing big. All right. So now we have things being displayed, and we're alternating back and forth between these guys' attacks, but these attacks aren't actually doing anything yet. All right. So we want to look at what does it mean to fight? Did we randomly generate who goes first, or we just choose the hero goes first? Yeah, we choose the random range between 0 and 2. So this will give us 0 or 1. And then we said, if it's 0, we'll set the current attacker to hero. If it's 1, we'll set the current attacker to monster. Or if it's not 0, hence the else. All right, so that just sets this global variable that we then use inside of update to get whichever is the current animator to tell it to set the trigger for attack. And this required us to create the animation for both our player and our monster guy to both have a trigger called attack. We had to make sure we had a variable name the same thing. Otherwise, this little, I don't know, mini trick won't work. If one of them has a attack player and the other one has an attack monster trigger, we won't just be able to say attack here. All right, so we will alternate who the current animator is. But we'll tell whatever the current animator is to do its visual attack thing. And then we'll swap who the current attacker is. That's all we're doing right now. All right. So we need to build in the logic here to actually take a swipe and try to hit the opponent. All right. So if our current attacker is the hero, that means we're going to be trying to attack our monster. Right? All right, so now one thing we can do is we can create a function to handle the fight. So we can have a function that takes in maybe the inhabitant that is the attacker versus and the inhabitant that is the defender. So that way we can write the logic for trying to clear their armor class and then doing some damage one time. And then just calling it with the correct two parameters and keep flipping them around based on who it is. So let's write a function. Now we're going to make it private because we're only going to use this inside of this class to just do our attacker versus defender ninja move thing. So we'll say private void. We'll call this guy try attack. All right, and this is going to take in an inhabitant called attacker and an inhabitant called defender. Now, is this allowed? Can I take in variables of type inhabitant when inhabitant was abstract? What does abstract mean again? Abstract says we cannot create an instance of it. Are we creating an instance of inhabitant here? Or is this just a variable capable of holding anything that is an inhabitant? Now, we happen to know the only things that will go into one of these two variables is either a player or a monster, right? Because those are the only kinds of inhabitants we can actually create. All right. But if we want to be able to hold a player as the attacker, and we also want to be able to hold the monster as the attacker, we have to go to the more generic variable container, inhabitant, that knows how to hold either of those animals. Make sense? All right, so that's why we're using inhabitant here. It's an important lesson with object-oriented and programming dealing with inheritance. Kind of those little nuances between what's an instance versus what's a variable, what are you allowed to do under different circumstances, which is why I keep asking basically the same questions over and over and over again. It's important to get that drilled into your head. All right. So when we're in here and we're writing this generically, we don't know which is the attacker versus which is the defender. We could ask the question. We can add, there's I think we had even looked it up last time. I don't remember what it was again at this point, but there is a Boolean operator in Java. It's called instance of C#. Anybody remember what it was when I looked it up? But there's an operator that allows us to say, is attacker actually a monster or actually a player? We can ask that question and get to the bottom of what kind of thing actually was stored inside of that generic container, if that was important to us. Right now, we have all of our logic with hit points and armor class and stuff like that stuffed into inhabitant, so we don't really need to make that differentiation. But as we go farther into this and we start deciding what makes a player different than a monster and so on and so forth, perhaps it might be important to be able to differentiate what kind of attacker we're dealing with here, because maybe they'll choose a different type of attack or something along those lines. All right, but we can keep it simple now. Just keep that in the back of your mind that we do have the ability to build if statements around is something actually an instance of a certain class when we're already holding it as a more generic version of that. All right, so what we want to do in here is we want to have the attacker try to attack the defender. So have the attacker try to attack the defender. Now, we decided that trying to attack the defender means to roll a 20-sided dice, which I'm just basing it off of Dungeons and Dragons D20 system. And if it's at least as high as the defender's armor class, that means you're going to hurt them. We don't know how bad you're going to hurt them yet, but we know we're going to hit them. If it's less than their armor class, you swing and miss. Okay, no damage done. All right, if you really want to get into some of the D&D things, if you roll like a 1 trying to hit them, maybe you stumble over your own feet and stab yourself in the shin or something, so you might take some damage with like a critical fail like that, but that'll be an exercise for the reader if you want to put in a couple of extra if statements. All right, so we're going to call this guy the attack roll. And we're going to go ahead and roll a d20. And what was that guy? Random range. So if random range, when I pass it, a 0 and a 2 gives me random integers between 0 and 1 inclusive, or 2 non-inclusive. And I want to roll, do you think about rolling a 20-sided die? You get numbers between 1 and 20. How can I use random range to generate a range that will give me a value between 1 and 20? Will that do it? Will that do it? Not quite. This will give me zeros as well. So how can I modify this to guarantee give me values between 1 and 20? What will that give me right now? Values between 0 and 19? How do we make sure that values in the range of 0 and 19 become values in the range of 1 to 20? Add 1 to it. So we'll add 1 to the result that comes out of that, not to the random number we're generating. So we'll generate a number between 0 and 19, and then whatever that number is, we'll add 1, which will give me a number between 1 and 20. Right? Okay. So that's my attack roll. So now we want to find out, is this attack roll large enough to hit the defender, whoever the defender is? And just as a reminder here, when we look at inhabitant, defenders, well, all inhabitants can tell me what their armor class is, regardless of whether they're monsters or players. So, back to my fight controller here, we can say if attack roll is greater than or equal to the defender, whoever that is, get a C. Then the attacker will hit the defender. Let's see how hard. All right. So only if the attack roll was at least as big as the defender's armor class do we actually hit. All right. So what will we do here? Well, we need another damage roll, and we can decide maybe damage is some value between 2 and 5, something like that. All right. So we'll say, and as you get into this, you might decide to differentiate the types of attacks. You might have magic attacks where you throw a fireball at them, which might do a bunch of damage, but you're limited in how many of those you can throw versus, stab at them with a little knife or something where you're, not doing tons and tons of damage, but you could do that all the time. Again, make the game your own. So in my game, damage roll is between 2 and 5. All right, so we'll set up random range again. All right, and I want it to be between 2 and 5. So if I have it generate a value between 0 and 4, that'll give me 0 to 3. And then if I add 2 to that, that'll give me 2 to 5. Damage between 2 and 5. All right. So now what we want to do is now the attacker is going to hit the defender for that much damage. Now notice here that we're not even using the attacker in any of this yet, right? Where we might start incorporating the attacker is with things like in these Dungeons and Dragons games, for example, a attacker might have some bonuses to an attack or something. Maybe they roll a 12 and it's as if they rolled a 15 because they have, higher dexterity or something. Ultimately, it comes down to how much detail you want to get. Right now, we're just dealing with hard-coded values. Roll a d20, hope for the best type thing. So we actually are not using our attacker here right now. But, whatever. So we roll our damage roll. This is how hard the attacker will hurt the defender. So now we need the defender to be able to take that much damage. And what does it mean to take damage? It means reduce their hit points. All right. So we'll go into inhabitant. Now, inhabitant has a way of getting the hit points, getting the armor class. So it's read only right now, but we have no way of taking damage or reducing the hit points. Now, we might want to, instead of letting somebody externally directly reduce the hit points, we might want to have a function maybe called take damage, something like that. So we can have a public void take damage. It'll take in a integer amount of damage. And then for right now, again, if you want to get more complicated with this, you can decide that if maybe you add another variable here, whether it was magic damage, and maybe certain inhabitants have resistance to some magic that dulls certain damage taken or whatever, but we don't have that in my game. So any damage we take just directly gets subtracted from hit points. This just gives us an opportunity to add in details about what taking damage ultimately means for this. All right, so we're going to say this dot HP is equal to whatever this dot HP currently is minus damage. So we'll whittle down their HP. All right. So now going back into our fight controller, it is the defender that is going to take some damage. How much damage? The damage roll amount of damage. All right. And that's what happens with try attack. Now, one thing we could do is we could have some like commentary. I think back to the old mud days. They would be like when you try to attack somebody, they would, it would kind of have like the attack things in red or something, and it would give you some commentary based on how hard you hit the bad guy. If you barely did any damage, it would say your attack grazes the the defender. But if you were like a really high level and you were attacking like a rat, your attack might have like liquefied him or something. It really got very creative. So you can decide if you want to do that, but because that will then give you a little bit of feel of the type of damage that is being done. If you have kind of a narrator there at the top that says, player takes 8 damage or something like that, rather than just us, we're going to be looking at the hit points tick down until somebody keels over or whatever. All right, so this is what try attack does. We take in an attacker, which we're currently not using, but we'll do it anyways. This could be a helpful thing for us at some point, as well as the defender, the person who's getting attacked. And it tries to do the attack, but it only is going to modify the hit points of the defender if the attack roll was high enough. Maybe if it wasn't, you can put a big message that says miss up there or something like that to let you know that the person tried to hit and they missed. But let's get this part working first. All right. So inside here, if the current attacker is the hero, we're going to say this dot try attack, and we're going to pass it this dot actually it's my singleton, right? My singleton dot the player. That's the attacker if the current attacker is the hero. And the defender would be this dot the monster in that case. Okay, so if the current attacker is currently the hero, before they flip-flop, we're going to try to do an attack. Similarly, down here, we'll do the same thing before they flip-flop. Where the attacker is the monster and the defender is the player. All right. Now, after this line, now the defender may have fewer HP. Check if they are dead. All right. So how do we ask that? Well, if we're in this if statement, that means the defender was the monster. And the monster is the only one that could have taken some damage in that last altercation. So we can ask the question if this dot the monster dot get HP is less than or equal to 0. We're asking the question, did they die? Right? And if they died, we want to have some sort of, I don't know, celebratory, the other guys jumping up and down. Maybe we play some music. I think the Final Fantasy was something like dun 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 dun. Perfect rendition. But we can decide what that's going to look like there. So maybe right now we'll just do a let's see, are we in a we must be in a mono behavior. So we'll just say hero wins, just to give us a little feedback. We'll have to ask the question here, how do we stop having dead things attack each other and stuff like that? So at some point the fight needs to end, but let's keep it at this right now. All right, so similar thing we'll ask is after the attack, we want to know if my singleton dot the player dot get HP is less than or equal to 0, then the monster wins. But at this point, they're going to still keep fighting back and forth. So we're going to see hit points go to the negative side of things. Now, at this point, though, we're never actually updating those hit points. We set them right up here with our the heroes and the heroes hit points and the monsters hit points. So we go ahead and grab the current information. So what we might do is we can either, just update it after each thing. So if the hero might have been the one who just took some damage, after the monster attacks the hero, we can update the hero's HP in case it reduced. We don't have to necessarily ask, did it reduce? The worst that happens is we're just setting it back to the old text. They had 15 hit points before, they still have 15 hit points after the last attack. Similarly, if it's the other way around and it was the monster that might lose some hit points after an attack, we'll update their stuff there. And this is just going to keep going in perpetuity at this point. And the attacks are going to go pretty quick. So we're going to see somebody, they're ultimately going to both go to below 0, but we at least should see this back and forth movement. So did we save everything there? Looks like it. So let's go ahead and see how fast it's going? And notice the animations aren't keeping up either, because of how long the animation takes and because we're watching this fight happen. First of all, they both have pretty low armor classes anyways. Okay. But remember, update gets called every single frame. So every single frame, somebody might get hurt, as we're seeing from this. We probably don't want it to work that way. So what can we do? We have our logic working now, and well, here I go to our console, we see monster wins, hero wins, because once they're below 0 hit points, it's going to keep triggering that same if statement. So we seem to be able to detect when somebody won, and we want to be able to stop the fight. So how do we do that? Let's start with that, because right now it's clearly the fight's over basically in less than a second. because we're probably running at 100 frames a second or something like that. So how do we make sure that that we stop having the fight inside of update once somebody has died? What's an approach to that? How do we get them to stop attacking each other? Could we maybe have a variable that may be called should attack? And as long as that variable is true, we're going to keep attacking. But as soon as it becomes false, we just won't attack. Maybe up here, we'll say private bool should attack and start that guy off at true, maybe. And then down here inside of update, all this stuff that we have in there is related to attacking right now, right? So we can say something like if this dot should attack, then we'll only do that stuff if we should be attacking. Now remember, this dot should attack gives me the equivalent output as if I say if this dot should attack is equal to true. This is redundant though. If you like this look better, it's fine. It's not going to really hurt anything. But if this dot should attack is true equal to true? Yes, it is. So it'll be true. So you actually don't need the Boolean operator here because this guy is a Boolean expression in and of itself. It will boil down to a single value of true or false, and it's the right value of true or false that we're interested in. All right, now as soon as one of our dudes wins, we want to say this dot should attack is equal to false. No more attacking, regardless of who won. All right, that will keep us from getting into this if statement on the very next frame. All right. Go back here. They should at least stop attacking each other now. All right. We saw the ghost had its final animation as it finally caught up. Man, our player really is not doing well here. Okay, so player died again. All right, so we have the fight. So in this case, the player won, and we have the hero wins thing down there. The logic will work out fine for the monster wins. The hero won again. Monster won that time. Okay, so we know we're capturing it in the right way. We know who won. We're not really depicting who won or anything at this point. But if we were going to look at the code right now and say, okay, well, what's the weakness? We're probably fighting too quickly, right? We want to have the suspense of attack. Maybe we want the attacks to last as long as an animation lasts or something like that. Or at least maybe we just make sure the time is longer than the animation. So we see the guy do his attack, come back, and then we see the damage go down or something like that. All right. So really all of this logic that we're doing right here inside the should attack, this is what should happen when we are doing an attack. But it's not necessarily something we want to happen every single frame because it's occurring too often. Fair enough? All right, so let's just take this logic and let's throw it into a function. And for right now, we'll make it a private function. We'll just call this guy fight. And we'll throw that stuff in there. All right. So now we can decide when we want fight to get called. We currently have a function called fight that will do its thing. If I call it right now, inside of start, if I say this dot fight right now, one attack will happen. They're not going to keep attacking because we're not relying on that update thing to keep doing it over and over and over again. So now we'll see first blood. All right, so it looks like probably missed. Still missing. I'm going to add a little commentary, at least in the text. So just like we're printing out hero wins here, let's just do a it's inside of try attack. So we'll do an else to the attempt to attack. And then we'll say print attacker misses, something like that. All right. So his hit points should have gone down. I didn't notice if they did. 11 and 14. Did they miss? Or are we not updating hit points? Inside of should attack, we're updating the hit points after try attack. But I didn't see hit points update. I'm not looking at the console. It's possible what's happening here is since we have our call to fight inside of start, the first time we're actually seeing their hit points is after their hit points were already diminished, because this is happening before things pop onto the screen. So let's leave that alone for a second. All right. So we had introduced, before I throw this out there. Okay. So now we have a function that does a single pass on fight. We don't want to have fight get called every single frame. How do we make fight get called maybe once every 2 seconds? Have we, go ahead. Those coroutines. So when we were comparing our thread type behavior inside of Unity, rather than working off the, let's call it the default thread that literally gets called every frame, we want this to feel a little bit more natural for a user. So we're going to, let's see, fight is going to be, what is it? I enumerate. Let me just look up coroutines real quick. Unity coroutine. Let's put that in there. So it's going to be an I enumerator. All right. And then we're going to start that coroutine. So let's start with that guy. So it's an I enumerator is the return type for fight. And inside of start, we can say start coroutine. And we're going to tell it we want to call that fight function. They have to give it the open close parentheses. All right. So this is the guy that starts our thread for fight. Now we need to put our delay in there. So this is where we, and notice the whole return dealio. So we can do a yield return, wait for some number of seconds. And let's make this 2 seconds. Because now we've advertised this guy must return a value. we're not really using the value anywhere for our purposes, but it's being used by the coroutine system behind the scenes. We still are only situationally attacking, but regardless, this function is going to return something after 2 seconds. Now, this pause, though, will happen at the end of our function. All right. So let's see what this ends up looking like. Okay, we're still only attacking once. So a coroutine acts like a thread. So it's running in the background. It's not connected to the number of well, it's not connected to the frame rate. But still, we're just launching a thread and saying, go and do this one time in the background. We really want that coroutine to continue going over and over and over again, right? Until we shouldn't be fighting anymore. All right. Well, we already know how to start a coroutine, and we also have logic in our code for when we shouldn't be fighting anymore. So if I go back to our code here, and inside of this if statement is where we know we're not fighting anymore, right? Inside of this if statement is where we know we're not fighting anymore. So we can have an else to these guys, and only in that else do we call the coroutine again, where we start our coroutine. Now, we probably want to make sure that we are updating our the current attacker to the other guy in preparation for the next round if there's going to be a next round. Because right now we're not going to be doing that. We'll have the same attacker attacking the same defender over and over and over again. So when is it safe for us to switch our current attacker and our current monster? Inside of this if statement here, we're not using current attacker. Once we're inside here, we know the current attacker is the hero. So we can right away flip it to the monster in preparation for the next time through here. Similarly, same thing's true here. We're not using current attacker inside of here. Instead, we know that the monster is the current attacker and they're attacking the player. If this changed, we wouldn't be able to make this assumption. All right. So now we can have our else start the coroutine so that the next time through, we do get our fight as long as they should be fighting. Now notice where this yield is for right now. Well, our hero did win. Notice the hit points is at 0. And notice that a whole bunch of stuff happened. Yet from our visual of this, it all happened instantaneously, right? Why is that? We only yielded at the end of the coroutine when we called that coroutine multiple times along the way. Make sense? So we need to have a mechanism for yielding ahead of that. Now, go back into my code. So we are waiting for some number of seconds here, but this happens at the very end where we're waiting for that number of seconds. Now, return, well, so let's just do it this way. Let's assume that I'm going to put this at the very beginning. So right at the beginning of fight, we go ahead and say yield, wait for 2 seconds, then do this attack thing. Okay, it's giving us the behavior we want. But let's talk about the return keyword here. So at this point, we're watching a fight unfold in a reasonable amount of time or whatever. Remind me, what does the return keyword do? Makes a function immediately end. Yet we just observed that this stuff is still happening, right? So when we return an IEnumerator, there is something about coroutines that when you have a thread in the background, there is a difference between the IEnumerator that is returned by it and the content inside of it. So these would be kind of a special case type thing. It's not very intuitive. If we hadn't tried this, we wouldn't have seen this, right? Even though most examples for coroutines have that yield statement right at the beginning. So if you were to go and just copy code from somewhere and put it in there, it would just work, but you may not ask the question of why this is working. This has to do with what the IEnumerator type is. Typically, enumerators are things that we where you might take a list of some stuff and you might turn it into something that is, I don't know, quickly iterable or something like that in a programming language. So this is probably a data structure used by the management tool for running your threads in the background, such as that it doesn't slow down your frame rate or something like that. All right, so at this point, we have our fight thing seemingly working out. All right, so just to kick it forward a little bit for the homework assignment, why don't we, I'll upload this code. Why don't we go in and put in some commentary on the screen so we get a little bit of text updates inside of this code of when there's a miss, when there's a hit. Maybe you can decide that there's going to be a, if they hit with a certain amount of power, it's a super hard hit, otherwise they barely graze them or whatever. You can decide, but let's just get some commentary so we see the fight unfold and don't just have to guess at the hit points. All right, so I'll put that assignment up. I don't think it should take you all that long, other than maybe just getting your project caught up here, but I will see everybody on Friday. Make sure I have all my stuff saved. Maybe we'll add in a death animation too to the assignment.
Disappear.
You can decide if you want him to disappear or you want to have him just go face up, just roll over. He's looking up at the sky.
You have to figure out how to make it just like shrink into nothing. So whatever size it is.
Oh yeah, I mean that you can certainly do that. I mean that would just be a change in scale. In yeah, I mean so it's
The animation stuff is annoying to work with.